Hi everyone, Unit 1, Algebra and Number, Section 2, Roots and Powers, Chapter 4. Okay, so there's some curriculum outcomes here. You're going to be able to develop algebraic reasoning in number sense. You're going to demonstrate an understanding of irrational numbers by representing, identifying, and simplifying irrational numbers. You're going to be able to order irrational numbers. And you're going to be able to demonstrate an understanding of powers with integral and rational exponents. Okay, so here's the checklist of all the things I want you to do this section. So you should have already done the powers and roots pre-assessment. If you haven't done that yet, you need to stop this video, go back up a card in the workspace, look at the pre-assessment, do that, show your teacher, let them release the key to you, and then you can start on all this material. Okay, so after the pre-assessment, there's 5 parts to this particular chapter, and then the same format as before. You'll have a formative assessment, kind of powers and roots review. Then you'll have a roots and powers curriculum review. That's the summative assessment. That's the one that counts for marks. And then you will have a powers and roots quiz. Okay, so that is just on chapter 4. That will end unit 1. So then after this, before you start the next chapter, the next unit, you will have a Unit 1 exam on chapters 3 and 4. Okay, so that is coming up at the end of this after your chapter 4 quiz. Okay, so we have lots to do, so let's get going. Part 1, irrational numbers. Okay, a number that has any kind of a root sign is called a radical. Okay, so consider this general radical. Okay, so here the I, that's called the index. So that's the number that's up top here. We see it in cube roots and fourth roots. Recall that in a square root, that number, square roots are so common that we don't actually put the 2. If you just see the square root symbol, it's assumed that that index is a 2. Okay, awesome. This number underneath the root sign, in this case the x, that is called the radicand. Radicand with a D at the end. Okay, so that is the part that's underneath the root sign, and then all together this makes up the radical. Radical, dude. Okay, so radicals that are square roots of perfect squares, cube roots of perfect cubes, and so on are called rational numbers. These radicals work out perfectly on the calculator. Rational numbers can be written as decimals that either stop or repeat. Okay, so those are rational numbers. Formally, rational numbers are numbers that can be written in the form a over b, where a and b are both integers, so positive and negative whole numbers. Basically, guys, a rational number is any number that can be written as a fraction. Okay? Irrational numbers, on the other hand, cannot be written as fractions. The decimal approximation for these types of numbers, the decimals, they never terminate, so they never stop, and they never repeat. Okay, the most famous of these numbers, of course, is pi, right? Never stops, never repeats. Okay, but any square root or cube root that doesn't work out perfectly on your calculator will be one of those irrational numbers. Okay, so root 2, that's a good one. Root 2 does not work out nice on your calculator. It gives a decimal, doesn't stop, doesn't repeat. The cube root of negative 50 doesn't stop, doesn't repeat. Okay, so those are examples of irrational numbers. Root 4, on the other hand, that is 2, works out perfectly. 2 can be written as a fraction, 2 over 1. So the square root of 4 is still a rational number. Okay? So when an irrational number is written as a radical, the radical is the exact value of the irrational number. Okay, so the exact value of root 2, it doesn't simplify anymore, so the exact value of root 2 is root 2. The exact value of cube root of negative 50 is cube root of negative 50. Okay, we can use the square root and cube root buttons on our calculator to determine the approximate values. Okay, so root 2 is like negative 1.71. Okay, that's a decimal approximation. It's not exact. Okay, so any of those decimals will always be approximate values because we can't write forever. We have to round it somewhere, which makes it an approximation. Okay, we can approximate the location of an irrational number on a number line. If we don't have a calculator, we can approximate using perfect squares and cubes. Recall that you were asked to memorize some of the perfect squares and cubes last unit. Okay, so that chart is shown on the next page. So let's have a good look at it again. Okay, so we have the x's, x squared, x cubed, and a few of the x to the fourths and x to the fifths. So look, if you were asked to place root 15 on a number line, you could look at the above chart or just know. Okay, look, 3 squared is 9, and 4 squared is 16. So the thing is, the square root of 9 then is 3. The square root of 16 is 4. So it's appropriate for you to say that root 15 is in between 3 and 4, right? Root 3 is root 9, 4 is root 16. Well, root 15 is in between root 9 and root 16. So it makes sense that this would be in between 3 and 4. Now, again, closer to the 4 side because 15 is closer to 16 than it is to 9. Okay? When we classify numbers as rational or irrational, it is best to put them as decimals and analyze the result. Okay? Of course, normal fractions are automatically rational numbers, as that's their definition. Rational numbers have decimals that stop, okay, terminate, or repeat. Irrational numbers have decimals that don't stop and don't repeat. Okay, so let's have a look at number 1. So it's classifying numbers. So tell whether each number is rational or irrational. Explain how you know. Okay, so negative 3/5, that is a fraction. Okay, by definition, that is a rational number. Okay, square root of 21. Well, let's see. Square root of 16 is 4, and square root of 25 is 5. So this is in between 4 and 5, but it doesn't work out perfect. So this guy is one of those non-perfect square roots. So by definition, that's irrational. Okay, so cube root of 27 over 64. Well, when we take the cube root of a fraction, we just cube root the top and cube root the bottom. So the cube root of 27 is 3. The cube root of 64 is 4. So this works out to a perfect fraction. Okay, so this one is rational. Okay, 1.41. Hey, look, that's a decimal that stops. Okay, so this is like 141 over 100. Okay, totally a fraction. This is a rational number. Okay, square root of 16 over 81. Same with the cube roots. We just square root the top and square root the bottom. So 4 over 9. Hey, that one, so that's rational. Okay, now let's look at this one. 1.101,001,0001. Hey, there's definitely a pattern there. The next one will be 0. So 1, 2, 3, 4 zeros, then a 1. Then there'll be 5 zeros and a 1. Okay, so there's definitely a pattern there. The thing is, it's not a repeating pattern. So it's not the same pattern over and over. You keep adding a 0. So this one here is an irrational. Okay, there's a pattern, but it's not a repeating pattern. Okay, so that is how we classify those. Okay, together the rational numbers and irrational numbers form the set of real numbers. Okay, so the diagram shows how all the number systems are related. Okay, so the natural numbers, remember those are the counting numbers. Okay, so the natural numbers are the smallest, and their symbol is n. So the natural numbers, and those are the counting, so you go 1, 2, 3, all the way up to infinity. That is a horrible infinity sign. Okay, great. Next, you have the whole numbers. Okay, so the whole numbers, that's W. Okay, and the whole numbers are 0, 1, 2, 3, 4, all the way up to infinity. There, that's, well, slightly better. Tilted a bit, but that's okay. Okay, next after the whole numbers is the integers. So those are the positive and negative whole numbers. So it goes all the way down to negative infinity, and then like -3, -2, -1, 0, 1, 2, 3, all the way up to positive infinity. So those are the integers. Okay, no decimals yet. Okay, next up you have the rational numbers. Now, I know what you're thinking. It should be an R. Okay, but it's not an R, it's a Q. Okay, and the Q actually stands for quotient. Okay, quotient because it can be written as a fraction. So these are all the positive and negative fractions. Positive and negative fractions. Now, funny, all the integers can be written as fractions over 1. So all the all the integers count as fractions. All the whole numbers count as fractions. All the natural numbers count as fractions. That's why the natural numbers are part of the rational numbers. That's why the whole numbers are part of the rationals. Okay? Now, in math, for the irrational numbers, well, you're either rational or irrational. You can't be both at the same time. So their symbol in math, when we say not something, we put a line on top. So the not Q's, the Q bar, if you will, okay, so those are the not fractions. Not fractions or the irrational numbers. Okay, so those are the irrational numbers, okay, and that's all the positive and negative non-fractions. Okay, together, the big square box there, that makes the real numbers, and that's the R, real numbers. Okay, so that is the positive and negative fractions and non-fractions, so all the numbers that we think of. Now, there is one extra set out here, okay. These are the non-real numbers. They're called imaginary. Okay, and I know what you're thinking. Why would you have imaginary numbers? Okay, but there is an imaginary number is like a square root of a negative. Okay, so let's say square root -1. Okay, now there are some applications of this number, the square root of -1, in engineering and some higher mathematics. We don't worry about that at all. So really, you don't need to know about the imaginary number system, but it doesn't hurt you to know that it exists. So there is a number system outside the real numbers called the imaginaries. Okay? Perfect. So those are all the number systems. Example 2. Ordering irrational numbers on a number line. Okay, so use a number line to order these numbers from least to greatest. Now, I need you to pay attention to that wording, least to greatest, because sometimes it says least to greatest, sometimes it says greatest to least. So depends on how you write your number line, right? But anyways, I've drawn the number line for you. It's all good. Okay, and all we're going to do here is we're going to type these into our calculator and get a decimal approximation. Okay, so root 2 is 1.414. Cube root of -2 is -1.260-ish. Okay, cube root of 6 is 1.817. Cube root of 11, 3.32. Sorry guys, I know this is fast. I've already typed these into my calculator. Now, if you guys want, you can press pause and type them into your calculator on your own if you want. Okay, fourth root of 30 is 2.340, and the square root of 50 is 7.07. So if we have a look at these, the order of these guys, okay, so this one, the -1.260, that's going to be first. So he's cube root of negative 2. So he's first. Now, the trick is when you put these on the number line, you don't put the decimals, you put the actual numbers. So negative 1.2, so negative 1.2, that's about there. Okay, and that is the cube root of negative 2. So you put that on like so. Okay, now who's next? So we've got 1.4 and 1.8. Okay, so the 1.4 is next, so that's root 2. So 1.4 is about there. So that's our root 2. Awesome. Okay, root 2. Okay, next up, so we got rid of those two. So we have 1.8, 3, 2.3. So 1.8 is next. So that's the cube root of 6. So cube root of 6 is 1.8-ish, so that's about there. Here, so we'll just draw an arrow. Okay, so that's the cube root of 6. Okay, so next up, that's the 1.8. So then we've got the 2.3. Yeah, so he's next. So 2.3 is about there. So that is the fourth root of 30. Okay, so the fourth root of 30. So he's done. Then you have root 11 at 3.32. So it's about there. So that's root 11. Root 11. So he's done. And then root 50 is 707. So that's like way up here. So root 50 is last. Okay, and that is how you order these things on a number line. So guys, that's the end of this section. So this is section 4.2 in your textbooks. You can use your textbook, or you can print the pages, the work pages off from the workspace card. I do encourage you to do that, because then you can write all over the questions and everything. It just makes it handy. So anyways, you can do that. Either way, the answers are in the back of your textbook, and those are the questions that you need to do starting on page 211. Okay, good luck. We'll see you next part.